Now the hyperbola is the one with a minus sign. So if we have x squared minus um, y squared, we do have the hyperbola. This time the a squared does not have to be the bigger number. It's whichever one comes first. The positive one, that's how come we know it's a horizontal parabola. More on that, how to graph it a little bit later. So because it's horizontal, we know that the parabolas, the vertices of the parabolas are on the x-axis, and again they have to do with the a. And the endpoints of the minor axis are on the y-axis. Now the hyperbola also has asymptotes, so the graph looks more like the two parabolas. Notice they are on the x-axis, so they're facing left or right. That's how come it's a horizontal parabola. Now the way we get asymptotes is we can draw a little rectangle. This is how I got the endpoints. These were the vertices, negative a and a, from the center, which is the origin to start with, and then negative b and b were the other endpoints. We can draw the rectangle with the endpoints. Now the asymptotes meet, they start at the origin, but they go through the corners of this rectangle. And notice the way we get the equation is if you count the slope of this line right here would be the rise over the run. So if the rise is b, because that's the vertical rise, over the run, which is a. So the slope of this line would be b over a x. Now the slope of this line respectively would be negative b over ax. And again we have the two parabolas which follow the asymptotes right here. And the foci, this time the c is actually the sum of a squared plus b squared. So it's actually bigger than either one of them. And again they sit inside of the two hyperbola portions right here. The vertical hyperbola looks similarly, but notice this time it's the y that comes first. So that's how come the transverse axis is basically the axis where the hyperbola sit on, and this time it should actually be a y-axis. There's a typo right here. As you notice, their vertices are on the y-axis this time. My apologies. Now, similarly, the asymptotes this time would be a over b, because the rise is a. Notice, here's the graph. So here's a similar rectangle, but this time a and negative a are on the y-axis, and negative b and the b are on the x-axis. And again, we have foci always inside of the hyperbolas. And again, now this time the rise over the run would be a over the b. And again, I usually find it easier to plot the rectangle first, and everything else kind of falls into place once you figure out which hyperbola it is. So here's an example of a horizontal hyperbola. Again, we find A and the B. That's how we form the rectangle. And the C helps us with the foci. And because it's a horizontal one, we have vertices and foci both on the x-axis. And so we get our rectangle. We call the A and negative A were 3 and negative 3. B was 2 and negative 2. We get the rectangle. And again, we can do rise over run, 2 over 3. And that's how come we get the equations for the asymptotes. Should actually be plus or minus 2/3 x. And again, the actual hyperbola portions, they start at the vertices right here. Right here they should start. And then they should follow the asymptotes. And then there was an example of a very similar vertical. Let's take a look at the graph for that one. Here's an example of the vertical hyperbola. Again, we have to find, I believe the A was 4, it was 5 and negative 5. So it should be 5. 1, 2, 3, 4, should be 5.